This is how you get more robust and accurate readings from your MPU6050. You need two things. That is, one, access to your DMP, and two, quaternion multiplication. A digital motion processor is an onboard processor built into the MPU6050 where a lot of mathematics and data fusion happen. So you can lighten the load for your Arduino. In order to access the DMP, you need an extra pin on your Arduino and the right library which calls upon the DMP. The library that I used has other advantages like quaternion multiplication. Unlike Euler angles to represent orientation, the quaternions do not suffer from gimbal lock. But we need the Euler angles to feed into our PID controller. So how do we do this? Well, every loop in our Arduino code, we make the calculations on the quaternions and we derive from these quaternions the Euler angles. So it looks something like this. You have a quaternion, and you make the calculation on the quaternion, and from these quaternions you you derive the Euler angles. This way, your system does not suffer from gimbal lock since the calculations happen on the quaternions. Now, if you don't understand what quaternions are, it's not really necessary because it's complicated math, but if you want, it certainly doesn't hurt, and I'll leave some resources which I find useful in the description. Now, how do we access the magical powers from this DMP? Well, you need, as I said before, an extra wire from your MPU6050 interrupt pin to your interrupt pin on the Arduino, which for the Arduino Nano is the digital pin number 2. And then you need to use a write library which accesses the DMP. The library that I used was the J. Roberg I2C devlib, which you can find on GitHub. And this is where we're going to go now. So once you're on the GitHub, you can simply download the code as a zip, extract it in, and put it into a file next to your other Arduino libraries. When you've done that, you can open in your Arduino file examples, and here you can find the MPU6050, which we are now going to open the MPU6050 DMP6 example. Scrolling through the code, you can see here the libraries that are included. These are the same libraries you've just installed. We also need the wire library, which is the library that enables the I2C communication with the MPU6050 chip. Here we initiate a class. The class is called the MPU6050, and we initiate an object named MPU. Scrolling further down, we can choose what values we want to be displayed on the serial monitor. So right now we are going to get the readable yaw pitch roll values, but we can comment this and uncomment, for example, the quaternions, and now we will see the quaternions on our screen when we open the serial monitor. Scrolling further down, we define our interrupt pin and some global variables which are used in the code. Even further down, we have the setup function, which just initializes the MPU6050 and makes a connection with the DMP. And when we go way more down, we see the loop function, which gets executed forever. And here we see the different hashtag ifdef and hashtag endif blocks. And each of these blocks it will be executed depending on which one you commented or uncommented. So right now, only this piece of code will be executed because we chose the output readable quaternion. When we want the output readable yaw pitch roll, we just select, we would have selected in the top of our code the output readable yaw pitch roll. Uh, I use the yaw pitch roll for my TVC rocket to feed into the PID controller. Now, when you don't want to have all the other code and just want the yaw pitch roll angles, I've made a new Arduino file which does just that. So here we include the libraries, the same code as before, it's just rewritten without all the extra stuff. And here is the setup function and the loop function. In the setup function, we initialize the IMU, and in the loop function, we get the values from the IMU. The initialize function is exactly the same as before, just rewritten in a function. And then the get IMU gets the values from the MPU6050. And right now, it only gets the values and stores them in the variables and containers we declared in the global scope of the code. But if you want to print the values, you can just simply uncomment this. And now you get the quaternions and the yaw pitch roll angles on your serial monitor. But that's not necessary to get the values. It's just simply explaining the values. To get the values, you just simply need this piece of code right here. Okay, so that was it. I think my job is done here, and I hope to see you in the next one.